you're about to ready to do that lock here with this lesson. This is why we've been prepping you for working with the division of radicals. So take question 1 and 2. This is where your calculator, again, might be the part where you need it. Question 1 and 2, rationalize if you haven't done so yet. Take questions 1 and 2, rationalize the denominator if you have not done so yet. All right, good if you haven't done so yet. And as you do that, I'm going to take attendance, it looks like. Everybody's here. Hopefully enjoyed yesterday because like we're getting that weather for at least another week or so. It was very nice yesterday. I know there's not a lot of room there in that little box. My bad. Maybe actually work to the side this time. Now, who cares what 18 times 18 is, right? I don't care. It's going to take you back to this 18, right? I did get your tests graded. I just hadn't had a chance to put those into Skyward yet. I'll do that later on today when I have a few minutes. Just didn't have any time. And then as we kept talking about things, again, it looked a lot better as we finally went through the rest of that topic. Simplifying what you can. 7/18, sorry, not 7/18. 7 square root of 18. 18 does go someplace, doesn't it? So 18, take it off to the side, and what does that become? 21 square root of 2, I think. And then, again, some of you have been stopping too early. That's good, but we can go a little bit further, right? 21/18 does reduce by 3, right? And that gives me what? What's that? 7/6? 7, yeah, 7 or 2 over 6. Okay, so always keep reducing until obviously you can't, but keep asking yourself if you can simplify, reduce, all that jazz. Okay. Now, as we said with division of radicals, and you're going to see that here again a lot this week, so you're going to get a lot more practice with division of radicals. It happens with special rights. That's what we're preparing you for right now. With number 2, you can start off one of 2 ways. You can reduce first, or you can rationalize first. And when you rationalize, you can do it one of 2 ways. Now, what do I mean reduce first? What could you do here to start off with?
You could simplify root 18.
No, sorry, question 2. Yeah.
You just times it by root 3 or simplify by 2.
Yeah, or 8 divided by 2, right? Yeah, simplify by 2. You could take 8 divided by 2, which is what, 4?
Yeah.
So what we could do is just make our lives ever so slightly easier and reduce the size of those numbers, as Sam suggests, reduce by 2 there. Or not, and just jump right into it and rationalize the denominator. It doesn't matter. If you don't simplify to start off with, you're going to need to simplify at the end. If you see that, cool. If you don't, you're not going to get anything wrong there. It's just you might make a mistake, though, with a little bit larger numbers. I'm going to go with that reducing first and then rationalize here at the end. And probably at that point, most of you could probably do that, keep track of that in your head as well, and get what? 4 root 3 over 3. And that's what you're going to probably run into a lot here today and this week is keeping track of some of this in your head with special rights. You're going to see, that, again, these patterns that are going to happen here in just a few minutes as we do these special right triangles. Okay, that's the goal. That's the idea, is to see this. Pythagorean theorem's nice, but sometimes we're going to see Pythagorean theorem can't always work. And what happens when Pythagorean can't always work? We got backups over this course of this topic. So let's start off here, and let's jump into using our good old Pythagorean theorem. So that's what I'd like to do on question 3 here real quick. Question 3 and 4. Take your Pythagorean theorem. Okay, that's all we have right now in our pocket is that tool of using Pythagorean theorem. And what I like you to do is find me out the values of x in both of these. All right, and then also find me the measure of the two missing angles in both those triangles. And then finish it up by classifying those two triangles. Obviously the right triangles, but go a little bit further than just say right triangles based off of what we've talked about so far this semester. So I'm going to give you about a minute on my watch. Go use the Pythagorean theorem, answer those out for me. Go, go, go. You awake, partner? Or probably not. You just do this thing. I'm fully aware of that. I would imagine so. Alright, so it's the Pythagorean theorem. Cool. That's everything. Give you another minute here. Again, we're going with simplest radical form. No decimals at all. Unless the directions tell you otherwise, then otherwise they cannot tell us. Okay. On this, go with questions 3 and 4. Extra both of them out. Alright, turn to your neighbor and check those questions 3 and 4. All those questions are there.
No, I only made that.
Monday's me. Nice. You have jello.
Yeah, give me some. No. Stop. Okay, let's go through that. So, what you should see ideally here is a pattern happening with these two types of triangles. So, on question 1 really quick, using Pythagorean theorem, you got 1, 1, and what did you get for the hypotenuse? 1 root 2. Now, the two missing angles, we've talked about this triangle from first semester. This type of triangle here, would you get for the two missing angles? 90 and 45 and 45. Okay, classify me that triangle. Yes, it's a right triangle, but keep going. It's not just a right, it is an isosceles right triangle. So those two things should kind of go hand in hand. When I say isosceles right triangle, 45, 45 should come into your head. Back and forth that goes. Now, you should be pretty much copy pasting all those answers into question 4 if you found them, except not 1, 1 root 2, but 3, 3. You should have gotten 3 root 2 right there. You should have got, what, the square root of 18, which then gives you 3 root 2. Again, you got 45, 45, and another classification of a, isosceles right triangle. Now, if I had another column there, and in that next column, I gave that same type of triangle, and let's say this was 10 and 10, well, what do you think the hypotenuse would be off of that? Oh my gosh, 10 root 2, okay? Now, if I gave you another one here, okay, and if I mark these as, again, isosceles right, let's go a little bit further here, and let's say this was 30 root 2, and I asked you to go backwards. What would the two missing legs be? 30. Right, so we got a pattern happening on these 45, 45, 90 triangles. So let's generalize that pattern here and go back at it. So what we have in this 45, 45, 90, this is going to be our reference triangle. Okay? We call this our reference triangle here. And on the SAT, they do not give you much, if anything, in terms of that formula sheet. But let's see. One of the two things they give you, so since they give that to you, I will give that to you as well. In the 45, 45, 90 triangle, how they give you that on there is stating this right here, that the two legs are marked up as S and S, all right? I don't know why they use S and S instead of, say, X and X or not. They use S and S on their formula sheet. So the reason why they say S and S is the two sides are congruent, or the two legs are congruent. So the legs are congruent to one another, and that's the isosceles part of that, okay? The two 45s are congruent to one another. That, again, means the opposite sides are congruent to another. We just got done with that relationship. And then when you went through and found 1, 1 root 2, 3, 3 root 2, 10, 10 root 2, there's this pattern always happening that the side, the leg of the 45, 45 is always going to be in this relationship that if you know one leg, the other leg's congruent, and this relationship is always going to be the leg times root 2. So the length of the, let's see, let me reverse that because that's not filled in right. The length of the hypotenuse is square root of 2 times the length of either leg, okay? So burn that into your head. When you leave here, you go into Algebra 2, you go into Pre-Calculus, you go into Calculus. This is the one that you're going to follow. My sophomores, if you just sign up for physics next year, you will be following that into your physics classes as well. For my kids that are, say, going into the shop classes, construction, the 45, 45, 90 triangle is one of those that is used quite a bit in the trade classes as well. All right, so the 45, 45, 90, kids know it. It's not going to go away forever. Well, I mean, it's going to go away but when you graduate probably. But if you are going to those types of fields, it's not going to go away for us, okay? Let's use it. Let's get to know it right there. All right. So with that in mind, let's take a look at a few examples with that here today. Take question 5, run through it if you haven't done so yet. I mean, it's all about knowing those relationships that are there. What angles do you have? That opposite side relationship, okay? Where's your hypotenuse at? That's always the key, identifying that. I mean, how we've been doing the hypotenuse since like day 3 in here with Pythagorean theorem, right? So that's the easy one. The other two are then the legs, which are always congruent. Tomorrow we'll switch it up with the 30-60, but we ain't there yet. So knowing right there that this is our hypotenuse, okay, and knowing it's a side root 2, all right, they use S root 2, okay, and the 45 is 3. What else up there is 3 then, the X or the Y? Yep. And then it's as quick as saying 3, 3, and the X is 3 root 2. I don't fall into this complacency of like, again, shut up, Mr. Gross, just get this done. Give me some time here. We'll switch it up here in just a minute on a couple other examples. But as I asked a few minutes ago with the 10, 10, 10 root 2, 30, 30, 30 root 2, here, what does that 2 root 2 represent? The leg or the hypotenuse? It's the hypotenuse. It's across from the right angle. So this one again is pretty quick to do because it represents the hypotenuse as 2 root 2. And the reason why you're able probably to just say the two legs are 2 and 2 is because the hypotenuse is 2 root 2. So what we're doing right here is doing a little bit of equation in your head. The reason why you can say this is 2, 2 like that is the root 2's are going to divide. What we're doing here is solving an equation dividing by root 2. Root 2's cancel, root 2's cancel. And just like I'm doing in my algebra classes with solving equations all semester, second semester, that's what you're doing. You're solving for S. The reason why you're able to say 2's like that is the root 2's cancel. But now letter number 7 here, it doesn't go as quickly like that. So make sure you're paying attention here because that's not going to happen in question 7. Okay. Number 7, same thing I'm going to ask you. The only thing that we got information on is the 2. What does the 2 represent? The leg or the hypotenuse? It's the hypotenuse. Now, the hypotenuse, though, you cannot just say the 2 legs are going to be like 2's as well. Okay? Because the 2 in this case is the hypotenuse. It is not this 2 root 2 here. So because it's not got that root 2 on there, you just can't go as quickly like we did on that one. We're still going to do the same thing that I wrote off to the side. You're going to set it equal to the side root 2. Using my reference triangle that I have over there, okay, we're going to set that 2 equal to S root 2. That's what we didn't want to solve out for. So how do you solve an equation here for the variable S? Divide by root 2, right? It's attached by multiplication, and the inverse of multiplication is division. So we're going to divide by root 2. Now, as we divide by root 2, we end up with this. Let's we just start off with our warm-up on. We end up with 2 divided by root 2. Can we have a radical in the denominator? No. Back in the last topic, this is the first thing we start off with. This is our warm-up for today. You cannot have 2 divided by root 2 left over like that. So we need to rationalize the denominator now. Okay? So let's go ahead and rationalize the denominator. All right, rationalize the denominator off to the side. 2 divided by root 2. Again, I would imagine a few of you can keep track of that in your head. That's fine, but I'm going to rationalize my denominator here. Okay, 2 root 2 over the square root of 4, and the square root of 4 is perfect. And what can happen here? These 2's will cancel out, and we're left with just root 2. And I know there's not a lot of room there, so if you need to go sideways, that's fine. Okay, so we're left with just root 2. Now that represents just the side. That represents just the leg of the triangle. So what we just found was the 2 legs, root 2 and root 2. Okay. Now, it doesn't just kind of roll off that tongue like the first 2 did. 3, 3, 3 root 2. 2, 2, 2 root 2. It still follows that pattern, root 2, root 2, 2, but it's just not as quick off the tongue as the other two are. Root 2, and 2. It follows that pattern that's there, but it's just not as obvious as the first two are. This is where students always trip up on. I'd say like 20% of the class will want to say, hey, this is 2 and 2. So let's think about that. If you're going to tell me this is 2, 2, and 2, there's only one type of triangle out there that can be 2, 2, 2. That's an equilateral, a regular triangle. This is not a regular triangle. This is an isosceles right triangle. You cannot have a right triangle where all three sides are the same. Okay? So root 2, you're going to do this skill right here. Divide by root 2 every flipping time. Okay? All right, one down. Let's do another one. Number 8. Now we're kind of mixing up now. Number 8. What's that 5 root 2 represent? Is that the leg or the hypotenuse? It's the leg. So use my reference triangle. Okay? Now that you know that's my leg, what's the other leg up there? Is it the M or the N? N is my other leg, so I'm half done there. Taking it from the leg out to the hypotenuse. Going from the leg to the hypotenuse, we're going to take that and take the 5 root 2 and multiply it by root 2. So do that. Take 5 root 2 times root 2. If I can multiply. So the leg is 5 root 2. Now take it times root 2. We're taking the leg times root 2. That's what our reference triangle says. It says takes the S times root 2. Where our S happens to be 5 root 2. So now we use our, again, radical skills from the beginning of the year. What's root 2 times root 2? And what's 5 times the square root of 4? Yep. Whoops. You said it and I wrote it. 10. So the M happens to be 10. Okay? Again, it doesn't roll off the tongue as nicely. 5 root 2, 5 root 2, and 10. But that pattern is still there. It's just not as nice to work with. Okay? So 5 root 2 is congruent. Multiply that by root 2 gives me that 10. These right here, these are the easy ones. Don't expect those very often. Okay? Those are the easy ones. Let's work on these. The challenge, not even challenge ones, but these are ones we gotta work on. Okay? All right, let's keep rolling here if you haven't done so yet. Flip it. Okay? Let's take the next one there. All right? Sketch me out that picture. You got yourself an isosceles right triangle. What's that code for? Sketch me that out. And when you got the leg that is 2 root 2, sketch out that picture that has that. Okay? Sketch out that picture. What's an isosceles right triangle? The leg of 2 root 2. And then go find the area and the perimeter of that triangle. It's all about the practice. If you go home today and or through school today, you don't take advantage of doing any of the practice, and you come in today cold without doing any 45s, your mini quiz is going to suck on Friday. It's going to really suck on Monday with that full quiz. So you better make sure you're doing the practice today, tonight on 45s. It's a pretty straightforward concept. And everybody does well, but if you're not doing that practice, the first quiz will suck. One leg is 2 root 2. Who cares whether the other leg is at? If one leg is 2 root 2, well, the other leg is 2 root 2. So when we say isosceles right, that's the picture I draw out and label out. Isosceles gets the marks like that, right angle. Okay, if you want the area and the perimeter, you've got one of those already. You've got the area. We've been telling you throughout the year, and even before me, your other teachers have told you, the area of a triangle is 1/2 base times height. So you've got the area already. I've just been kind of emphasizing to you the area of a triangle has to be perpendicular. The base and height have to be perpendicular to one another. So let's do the area of a triangle first. Okay, 1/2 base times height. So we've got the base and height right there. in a right triangle, the base and height are perpendicular to one another. So we're done for the area. What's 2 root 2 times 2 root 2? I know we don't have a lot of room there, so let's just take it up top here. Can you correctly multiply 2 root 2 times 2 root 2? All that work that we've been doing with literally everything with dividing radicals over the last month or so. What's 2 root 2 times 2 root 2? 2 times 2, root 2 times root 2. 2 times 2 is 4, and root 2 times root 2 is the square root of 4. And 4 times 2 gives me 8. And half of 8 takes me back to 4. Alright, so half of 8 takes me back to, I'll write that out. So the area is 4. Do I have units here? No. So 4 units squared. And I'll write the area of a triangle right there. Okay. Only thing we're missing is the perimeter of a triangle. Got to have that third side. Now we know how to find it from the previous side. Do your 45, 45, 90 triangle. So we're using our reference triangle. Side root 2 for the hypotenuse. Whatever the leg is, leg root 2. We know what the leg is. It's 2 root 2. So take that 2 root 2, plus you. Multiply it, plus you again. Multiply it by leg root 2. Multiply it by, alright, root 2. That's it. You know that 45, 45, 90 reference triangle. It's going to be over there, and I'll erase it on Friday. We're going to keep bouncing back to it. On Friday, I'm going to erase it off the board. So get to know it. It only comes through practice. Just like the Pythagorean theorem did. Multiply it together correctly. 2 times is a 1 here. Square root of 4, and this square root of 4 times, sorry, square root of 4 is 2, and 2 times 2 is, so the hypotenuse is 4, I believe, right? Now again, that pattern's there. It's just not as nice as 3, 3, 3 root 2, 5, 5, 5 root 2. That's a nice pattern. This just doesn't roll off the tongue very well. 2 root 2, 2 root 2, and 4. All right, so the perimeter. This plus that. Like terms. Back to adding radicals. Everything that is old is new again. Like terms, like terms. This is the reason why, again, we've been reviewing all that work leading up to this topic. Not just to torture you. Maybe torture a couple of you. Sam, you know me. Okay, 4 root 2 plus what? 4? 10. Make it quick. All right, next one here, number 10. I'll give you a minute here, chew on that, so we can finish up some things here. We're looking okay on time. So take a minute on number 1. We've done a bunch together here. Give you a minute on number 1 there. Okay. Looks like we'll be fine. We're looking good. On your own, don't wait on me. Working through that one. I always like to throw this one out here at this point, give you a chance to chew on it, because what are you using on number 10 there? I'm hoping you're not using 45, 45, 90 on that one. What are you using on that one?
30, 60.
I hope not. Because have we talked about 30, 60, 90 yet?
No, but you wrote it to us.
I did write that. That's a preparation for tomorrow, so the janitors don't erase my board and put save on there. All right. So, what else have we used on there throughout the school year? Don't forget about, Lucy?
Pythagorean theorem.
Don't forget about Pythagorean theorem. Okay? So on this one, a squared plus b squared equals c squared. What's my hypotenuse up there? So just because we're talking 45s today, still don't forget about Pythagorean theorem. Okay? That's, you see this root 2, and I specifically put this one on there because it has a root 2 on this one. Not necessarily to trick you up, but to keep you on your toes with Pythagorean theorem. So this is our good old Pythagorean theorem. Now with this one as well, the other thing to keep in mind on is that 5 root 2. What have I been trying to stress to you about that 5 root 2 throughout the school year? You better put that thing in parentheses. I'd say we're about 75% of the way there. There's still a quarter of you that refuses to use those parentheses. That's fine. Proceed to continue miss quick 2 points every single time. All right. 5 root 2 correctly gives you what? What's 5 root 2 squared correctly? It should be 50. Incorrectly is going to give you 10. So you want to keep doing and missing those 2 points. That's up to you. And then 15 squared, you should know, is what? 225, I believe. Okay. So subtract 50. If you're going to subtract 10, that's fine, but you should be subtracting 50. What's that give you? What, 175? And then we can square root it. And again, the directions, we're not doing any type of decimals. The directions doesn't say anything, so we always default to simplest radical form. And what's my simplest radical form? 5 square root of 7. That's an old school from day one. Don't forget about good old Pythagorean theorem. If you don't see anything about the angles up there, you got 2 sides, you better be doing Pythagorean theorem. Okay. All right, let's do about graphing line. Let's go graph that line, please. Let's figure out what question 11 is talking about. Okay, let's go graph the y-intercept. Let's go back to 6th grade. Let's graph the line. The y-intercept is what here? The y-intercept is -2. Y-intercept is -2. Let's start there. And what's my slope? My slope is what? Crickets are concerning. 1 over 1. So let's go play the slope game and up 1, right 1, up 1, right 1. Up 1, right 1. So as we're doing this reviewing and we're doing the next steps in my Algebra 1 class with systems of equations, up 1, right 1, graphing a line is the same thing as saying going up 1, right 1 is the same as saying going down 1 and left 1. Take your ID and make a line. So we graph that line. That's the first part. Now what the heck does it mean? It says, find the measure of the acute angle that each line makes with a horizontal line. So what's a horizontal line look like? Okay, left to right. Here's our graph line. Draw in a horizontal line. What's a horizontal line? Okay, there's a horizontal line. Where's an acute angle that's being created with the horizontal line in our graph? Isn't that a acute angle that I just highlighted, right? We want to find the measure of that angle. Now, to find the measure of that angle, well, let's think about this. We can make a triangle. Let's make a triangle up there. All right, let's make the triangle. Let's make any type of triangle. What I mean by make a right triangle here is, let's go from this point right here. I'm at x is 2. Let's go straight down and make ourselves, the only triangles we've been really focused on are right triangles. Now, bless you, count me that horizontal and vertical leg right there, just like if you were doing the Pythagorean theorem. What's this horizontal leg right here? What's that length? That's a length of what? 1, 2, 3, 4, 5. And what's that vertical leg? Did I count right? I did not count right, did I? 1, 2, 3, 4. My bad, I did not count right. Try that again. Idiot. That's a length of 4. And what's the vertical leg? 1, 2, 3, 4. Okay. So we want the measure of that angle right there. What's the only triangle that we know has a setup up like that? What type of triangle did we just create? A right triangle that is also what? Isosceles. So what is an isosceles right triangle? What's the measure of that angle that we just highlighted? It's got to be a 45. So on this particular one, the measure of that angle is, it's a 45-degree angle there. The reason why this is happening is, what was our slope? What was our slope? Our slope was 1 over 1. For every rise we did, we went over 1. Up 1, right 1, up 1, right 1. It doesn't matter where you did the horizontal line, and it doesn't matter where you did the point to draw and create the triangle. If I took and did it right here for my right triangle, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's the same, it's just a bigger one. It's a similar triangle, right? Those similar triangles we just quizzed you up on, these are sharing the same angle. It's a bigger triangle, again large, 6 and 6. It's still a 45-degree triangle. It's because that we are still doing the 1 over 1. It's still the same slope, okay? Up 1, right 1. So everything is all because of that slope. 1 over 1 still giving me that same increase each time. All right, for time's sake, we're going to do one more here. We're going to skip over B. Let's do one last one here. Let's do number 10, and we'll call it a day after that. All right, find me. This we've done shared sides before. We got to find that shared side right here, Y, and we'll carry that into over in the other triangle to help us find X. So take that 10, and then let's find Y, and then we'll use that Y to find me X. All right, so what does that 10 represent in that left triangle? Is that the leg or the hypotenuse? So if it's helpful for you, like we've done before, redraw that picture, okay, with that Y that we have. As I hear, that is the hypotenuse there. And in our reference triangle, that is the S root 2. Now, unfortunately, that's not a quick, hey, it's going to be 5. It's not going to be 5. You do need to do some work of dividing. The reason why I know it's not going to be just a quick 5 because it doesn't say 10 root 2 at the end. It has to have a root 2 at the end of that. Let's divide and let's rationalize. So now you got to rationalize right here. Rationalize the denominator. You're going to divide by root 2 every flipping time. Rationalize the denominator. If you can keep track of that correctly in your head, more power to you. If you can't, who cares? Do the algebra work. 10 root 2, denominator. Root 2 is the square root of 4, and the square root of 4 is 2. Can you do anything more with that? 10 over 2 becomes 5 root 2, I believe. Okay. So we just found that shared side to be 5 root 2. You do enough of these tonight on the homework, you're going to do that, keep track in your head. I'd say at least half of you will be able to keep track of it in your head. 5 root 2. So we just found that shared side to be 5 root 2. Now, that's the shared side. Now, in the right triangle, we need to find X. What does that 5 root 2 represent in that right triangle? That 5 root 2 represents the what? Leg or the hypotenuse? It's the hypotenuse, right? It's the hypotenuse in the right triangle. And that one's nice because that one does represent our 5 root 2. So what we can do there is just say, hey, because that's the 5 root 2 in the hypotenuse, I'm done. X is going to represent what? X is going to be 5. If you don't see that, fine. Then set 5 root 2 equal to the hypotenuse, which is always S root 2. And those root 2's will again cancel out. and that's why you can say 5. Okay. So x is 5. Okay. We're not going to do the perimeter. Who cares? Okay. Now, that's day 1. 30/60s go quicker tomorrow because you got the idea of what we're going to be doing. All right. We passed out the assignment for the last couple minutes of class here. So one more time, as I tell you, another attempt the homework here today. If you got free time during your 4th hour or something like that, tonight as well. Becoming whole tomorrow without having done any of this stuff does make your life a lot more difficult than it needs to be come Friday. Tomorrow we'll do, as I said, the 30/60s. I'll give you one more reference triangle to memorize, and that will be it. Now, on Friday's mini quiz, I will not give you those reference triangles. I will not give you the SAT sheet for you. You have those reference triangles memorized. Usually what happens with students is, kind of mix those up in your head, practice them now so you don't do that. Okay? And we'll go through things tomorrow on Thursday. Friday's a mini quiz to touch base on.